Have you ever looked at a chemical equation and just felt a little lost? Well, you are in exactly the right place. In this explainer, we're going to take all that confusion and turn it into confidence. We're going to balance these things step by step.
So here's our game plan. First, we'll tackle the why. Then we'll look at the parts of an equation, go through the balancing process together, add some pro-level details, and then you'll get a chance to try it yourself.
Okay, first things first. Why do we even bother balancing equations? Is it just some random rule? Nope, it's actually tied to one of the most basic, fundamental laws of the entire universe.
This is it. This is the big one, the law of conservation of mass. This simple idea is literally the only reason we have to balance equations. It means that whatever you start with in a reaction, every single atom has to be there at the end. Nothing just vanishes into thin air, and nothing new just magically appears.
A balanced equation is basically our way of proving we're following that law. Think of it like a strict accounting system for atoms. We have to make sure the number of atoms for each element on the left side, what we call the reactants, perfectly matches the number on the right side, the products.
All right, now you can't fix a problem until you know how to spot it. So let's take a look at the anatomy of an unbalanced equation, which is sometimes called a skeletal equation. Here is a super common example. Magnesium, or Mg, reacts with oxygen, O2, and you get magnesium oxide, MgO. This is what we call a skeletal equation. It tells us what's in the reaction, but it doesn't tell us the correct recipe or how much of each thing we need. And this table right here shows you the problem clear as day. Let's do a quick head count. For magnesium, we've got one atom on the left, one on the right. Okay, we're good there. But look at oxygen. We start with 2 oxygen atoms on the left, but we only end up with 1 on the right. So where'd the other one go? It can't just disappear. This equation is definitely unbalanced. Okay, time for the main event. This is the equation we are going to wrestle into submission together, step by step. We've got iron reacting with water to make iron oxide and hydrogen gas. You can see right now it looks like a bit of a mess, but don't worry, we're about to fix it. So how are we going to do this? We're going to use what's called the hit and trial method. Now, that might sound like we're just guessing, but it's not random at all. It's actually a really methodical way of adjusting and checking until the whole puzzle clicks into place. Here's our 4-step strategy. First, we'll list out all the atoms to see where we stand. Then, we'll start adding coefficients. Those are the big numbers we can put in front to balance things out, one element at a time. After every change, we update our counts. And we just keep repeating that loop until everything is perfectly matched up. Let's get to it. Okay, step 1, let's take inventory. On the left, the reactant side, we've got 1 iron, 2 hydrogens, and 1 oxygen. On the right, the product side, we have 3 irons, 2 hydrogens, and 4 oxygens. You can see only hydrogen is balanced right now. Yeah, we've got some work to do.
So where do we start? Well, a pretty good pro tip is to start with the element that's in the most complicated-looking molecule. In our case, that's the oxygen in Fe3O4. We see we have 4 oxygens on the right, but only 1 on the left. So our first mission is clear. We need to get 4 oxygens on the left side.
And how do we do that? We just put a big 4 in front of the H2O. Now, this brings up the number 1 most important rule of balancing. You can only change the big numbers in front, the coefficients. Never, ever, ever change the little subscript numbers. If you change the 2 in H2O, it's not water anymore. So adding this 4 gives us our 4 oxygen atoms, but notice it also affects the hydrogen. Let's update our list. Okay, awesome. Oxygen is now balanced, 4 on each side. But by fixing the oxygen, we've now got 4 times 2, which is 8 hydrogens on one left. This is a totally normal part of the process. You fix one thing, you might knock something else out of balance. We'll just fix that next.
Our new tally tells us exactly what to do. We have 8 hydrogens on the left, but only 2 on the right. So, you guessed it, our next job is to get 8 hydrogens on the product side.
So how do we turn 2 hydrogens into 8? Well, the hydrogen on the right is H2. So what number times 2 equals 8? That's right, it's 4. So we'll place a coefficient of 4 in front of that H2.
Let's check our work again. Oxygen is still good, 4 and 4, and now hydrogen is balanced, 8 and 8. Look at that! We are so close to being done. Just one more element to go.
The last piece of our puzzle is iron. We've got 3 iron atoms on the right, but only a single one on the left. This should be a nice, easy fix.
All we have to do is place a coefficient of 3 right in front of the Fe on the reactant side. And I think that's it. It looks like we're done. But in chemistry, you always, always, always do a final check.
Okay, final roll call. Iron, 3 on the left, 3 on the right. Check. Hydrogen, 8 on the left, 8 on the right. Check. Oxygen, 4 on the left, 4 on the right. Check. It's perfect. Every single atom is accounted for. We did it.
So we've done all the heavy lifting of balancing. Now let's add the finishing touches. A balanced equation is good, but a fully informative balanced equation, that's even better.
We can add a lot more information by just including the physical state of each substance. It's really simple. We use S for a solid, L for a liquid, G for a gas, and AQ for aqueous, which is just a fancy way of saying it's dissolved in water. And here is our final, polished, beautiful equation. The iron is a solid, the iron oxide it makes is a solid, and the hydrogen is a gas. But check this out. Look at the water. That little g tells us something really important. This reaction happens with steam, not liquid water. See how much more information that gives us? So there you have it. We went all the way from a fundamental law of physics to a fully balanced, detailed chemical equation. You know, the best way to really make this stuff stick is to try it yourself. So now, it's your turn.
Here's a challenge to test out your new skills. What's the balanced equation for solid sodium reacting with liquid water to produce sodium hydroxide dissolved in water plus hydrogen gas? Go ahead and pause the explainer, grab a piece of paper, and use the exact same steps we just went through. You've got this. Good luck.